Alright, welcome to another video in our series of videos, basically providing the solutions for the second in-course exam for Math0100, which of course is preliminary Math 1. So we're on to question 4, which has to do with differentiation and applications of differentiation, like finding the gradient of a tangent and of course the equation of a tangent to a curve at a given point. So the first part of the question, part A, says find dy by dx of the following functions. So the first function we get is y is equal to 3x squared plus 1 times cos x. The second, y is equal to x plus sin x all over x plus cos x. Part B says given the function y equals 4 over 1 minus 2x, find dy by dx. That's part 1. Part 2, find the gradient of the tangent at the point x equals 1. And 3, hence find the equation of the tangent at the point x equals 1. So of course we'll start with part A, and the first function y is equal to 3x squared plus 1 times cos x. So looking at this, we should be able to recognize it as a product. So the product, of course, we normally call the one part u and the other part v. Of course, multiplication is commutative, so it really does not matter which part we let be u and which part we let be v. Once differentiated correctly, they will always give the same result. So, right, so we're going to say let u equals 3x squared plus 1. Now, if u is equal to 3x squared plus 1, then it means that du by dx. So to differentiate this, we keep our multiplying constant 3. It's a multiplying constant, and so we keep it. Then we're going to differentiate x squared. To differentiate powers of x, we bring the power down, multiply by it, and then reduce the power by 1. So this gives us 2x. And of course, 1 is a constant. We differentiate 1, we get 0. There's no need to write plus 0. So that's du by dx. Now let's differentiate v. So if u is equal to 3x squared plus 1, then v is equal to cos x, the other part of the product. So v is equal to cos x, which therefore means that dv by dx is equal to minus sine x. When you differentiate cos, you get minus sine. So we found the derivatives of the two parts of the product, and now we basically have to apply the product rule. So according to the product rule, dy by dx is equal to u dv by dx plus v du by dx. Right? Now some people are used to writing it the other way around, v du by dx plus u dv by dx. Nothing is wrong with that, especially since, of course, addition is commutative. So the order in which you add two numbers or expressions doesn't affect their sum. Another reason why somebody, or some people rather, tend to put the v du dx term in front is to help with the quotient rule, which we, of course, shall look at later when we apply question 2. So let's continue and proceed as it is. So we'll substitute for u dv by dx, then v and du by dx. So this gives us that dy by dx is equal to u, which is 3x squared plus 1. So we get 3x squared plus 1 times dv by dx, which is minus sine x. And then that is plus v, which is cos x, times du by dx, which of course we can go back up here, expand it out, 3 times 2x, that is equal to 6x. Alright? So this is cos x times 6x. So we basically simplify, put the positive term in front. So this basically becomes, let's put this one in front since it's positive. This is 6x cos x. And this is minus 3x squared plus 1 sin x. And there we have dy by dx obtained by using the product rule. So that is part 1 of part A. We'll look at part 2 of part A. So we'll write the equation. We have y equals x plus sine x divided by x plus cos x rather. So again, this is a fraction basically, and we're going to have to apply the quotient rule. So when it comes to the quotient rule, the numerator is often let to be equal to u, and the denominator is v. So we let u equals x plus sine x, and of course we find du by dx. So du by dx is equal to, when you differentiate x, we get 1. So this is 1 plus, we differentiate sine x, we get cos x. So that's the derivative of u du by dx. Now let's do the same for v. So let the denominator v equal x plus cos x. And so dv by dx equals, again when you differentiate x, we get 1. Right? So this is 1. When you differentiate cos x, we get minus sine x. So this becomes minus sine x. So we have du by dx, and we also have dv by dx. Now according to the quotient rule, dy rather, so dy by dx is equal to v du by dx minus u dv by dx all over v squared. Now earlier in part 1, I mentioned that some people prefer to put the v du ux term in front or first, and then so they write v du by dx plus u dv by dx. And that is a way of helping them to remember that basically when it comes to the quotient rule, it's the v du dx term that comes in front. So for some people that is basically a way to avoid making a mistake of not putting v du by dx in front when it comes to applying the quotient rule. Alright, so let's continue. So we're going to then substitute. We know what v is, we know what du by dx is, likewise dv by dx and u. So this gives us dy by dx is equal to v, which is x plus cos x, times du by dx, which is 1 plus cos x, minus u, which is x plus sine x, times dv by dx, which is 1 minus sine x. And this is all over v squared. And of course, v is equal to x plus cos x. So this is all over x plus cos x squared. Alright? Now, if you look back at the question a bit, the question asked us to just find dy by dx. It made no mention of actually simplifying as far as possible. Right? So if all you're required to do is find dy by dx, then there's absolutely no need to simplify this any further. Right? So in an exam, if it only asks you to find dy by dx, then you basically find dy by dx and you leave it as it is. But if it asks you to simplify as far as possible, then you basically proceed to simplifying. So because we were not asked to simplify this, we'll leave it at that. And so that is what dy by dx is equal to. Alright, so we're going to move on to part B, where we're going to look at one application of differentiation. So part B. Part B says, given the function y equals 4 over 1 minus 2x, 1. Find dy by dx, 2. Find the gradient of the tangent at the point x equals 1, and 3. Hence, find the equation of the tangent at the point x equals 1. So write the function or the equation. We have y is equal to 4 over 1 minus 2x. And they want us to find dy by dx. Now, there are a couple of ways we can do this, right? Now, it clearly looks like a fraction. And to many people, once it looks like a fraction, they will often use the quotient rule. Nothing is wrong with that. As a matter of fact, I will differentiate it twice. I will use the quotient rule first, and then of course I'll write it another way and I'll use something else. So let's look at the quotient rule per se. So in this case, the numerator is 4. So of course we let u is equal to 4. Now u is equal to 4, then it means that du by dx is equal to 0. So 4 is a constant. And so when you differentiate a constant with respect to x or any other variable, then the result is 0. Right? Remember, when you're differentiating, what you're doing is basically finding a rate of change. And if something is constant, the rate of change is 0. So therefore, when you differentiate a constant, you get 0. So u is equal to 4, which means that v is equal to 1 minus 2x, which therefore means that dv by dx, differentiate that, you get 0. So this becomes minus 2 times 1, which is equal to minus 2. So du by dx equals 0 and dv by dx is equal to minus 2. So by the quotient rule, dy by dx is equal to v du by dx minus u dv by dx all over v squared. Now substitute. So du by dx, of course, is equal to 0. So regardless of what v is, this first term will simply be equal to 0. So this gives us 0. Put back our minus sign. U is equal to 4. So put the 4. dv by dx is equal to minus 2. So we'll put a minus 2 there. And this is all over 1 minus 2x squared. Minus 4 times minus 2 gives us plus 8. So this is equal to 8 over 1 minus 2x squared. So that's dy by dx by applying the quotient rule. Now I'll do it another way, and of course whichever method you're more comfortable with, you could stick to that, right? So let's look at it again, right? We're going to use a different approach. So we're going to write it as y is equal to 4 times 1 minus 2x to the minus 1. How is that possible? Well, basic law of indices. Once you have from your laws of indices, basically if you have something like 1 over x, and that is equal to x to the minus 1. And this is basically, the 4 is just a multiplying constant, right? So we'll write it as that, and now it looks like a composite function. And therefore, because it looks like a composite function, we'll apply the chain rule. Now there are two ways of applying the chain rule. There's a longer version and there's a much quicker version. In an exam, of course, where time is of the essence, then it would be recommended that you basically stick to the shorter version of applying the chain rule, which is what I'll be applying to this one. So here goes. So we say dy by dx equals, now we keep our 4 because the 4 is a multiplying constant. I'm going to put a square bracket first, right? So put a square bracket, then we proceed to differentiating 1 minus 2x. When differentiating the composite function like this, the first thing we do is to basically treat it as if it's a regular derivative. We'll bring the power down, multiply by it, and then reduce the power by 1. So the power is minus 1. The minus 1 comes down. We put back 1 minus 2x inside the brackets. Reduce that power by 1 to give us minus 2. Not 0, but minus 2. Students often make that mistake. So minus 1 is equal to minus 2. Then now, we have to multiply by the derivative of what is inside the brackets. Inside the brackets, you have 1 minus 2x. And so you have to multiply by the derivative of 1 minus 2x. And of course, close our square bracket. So this basically means that dy by dx is equal to 4. We have minus, so let's just write it as, well, minus 1 over 1 minus 2x squared, which is basically what that is. And then now we have to multiply by the derivative of that, which is minus 2. So times minus 2. So this now becomes, now minus 1 times minus 2 rather. So this becomes 4 times 2 over 1 minus 2x squared. Which of course gives us 8 over 1 minus 2x squared. The same result as we got when we applied the quotient rule. So I showed you two methods basically. Naturally, you'd probably feel more comfortable sticking to one method. So whichever method you're more comfortable with for differentiating something like this, you could always stick to that method, right? So that was part 1. So we know what dy by dx is, and we'll be using it to do parts 2 and 3. So just write down what we got for dy by dx. So dy by dx is equal to 8 over 1 minus 2x squared. Now part 2 of the question basically asks us to find the gradient of the tangent at the point x equals 1. Now how do we go about doing that? Now let's track back a bit. Now what exactly are we doing when we differentiate a curve to find dy by dx? Excuse me. Essentially what we're doing is we're finding what is called the gradient function of the curve. So for any curve y equals f of x, dy by dx gives what is called the gradient function of the curve. What is the gradient function? the gradient function basically is a function which represents the tangent to the curve, and it basically allows us to find the gradient of a particular point on the curve by substituting a known point into the gradient function. So in this particular case, the gradient function dy by dx is equal to 8 over 1 minus 2x squared. And if you want to find the gradient of the tangent at a particular point on the curve, all you have to do is basically substitute the given x coordinate into the gradient function, and that will give us the gradient of the curve at that particular point. So at x equals 1, dy by dx is equal to 8 over 1 minus 2 squared, which gives us 8 over minus 1 squared, which is equal to 8. Since minus 1 squared is 1, 8 divided by 1, that gives us 1. So at x equals 1, the gradient of the tangent to the curve is equal to 8. Now for part 3, it says, hence find equation of the tangent at the point x equals 1. So part 3 wants us to find the equation of the tangent. Now how do you go about finding equations of a tangent? Now the tangent is basically a straight line which touches a curve at a given particular point. So let's say your curve looks like this. Then we have a tangent here. Then there's a straight line which touches a curve at a single point. Alright, so a single point. So this is a tangent. Alright, and this of course would be the curve. Now if you want to find the equation of the tangent, then essentially the requirements are the same as find the equation of any given line. To find the equation of a line, what do we need? We need a point on the line, or the coordinates of a point on the line, and we also need the gradient of the line. So do we have these things? So in part 2 above, we found the gradient of the tangent at the point x equals 1. So we satisfy the second requirement. Do we have a point on the line? Well, we do have the x coordinate, and we have the equation of the curve, so we can easily find the y coordinate. So let's go ahead and do that. So y is equal to 4 over 1 minus 2x. So x equals 1, y is equal to 4 over 1 minus 2, which gives us 4 over minus 1, which is equal to minus 4. So therefore, we now have our point 1 minus 4, and we have the gradient minus 8. And we can proceed to find the equation of the line using the equation, of course, y equals mx plus c. So x equals 1, y equals minus 4, the gradient m equals minus 8. So we have minus 4 is equal to minus 8 times 1 plus c. Minus 4 is equal to minus 8 plus c. So minus 4 plus 8 is equal to c. And so c is equal to 4. And therefore, we get y is equal to mx plus c. And the equation is therefore y is equal to minus 8x plus 4. And that is the equation of the tangent for this particular curve at the point where x equals 1. So that was question 4 from the second in-course exam for Math0100 preliminary math. Again, I encourage you to basically like the video, share it, and subscribe to the channel.